So this is a prequel because sometimes this stuff can be confusing, but okay, we have a cell, a particular cell in your body. And inside of the cell, we have a nucleus. And then we have some DNA. Basically, it's a couple of double stranded strings of DNA and nucleotides, right? And the first thing that happens is, let's see, what color can I use? Is the DNA gets transcribed. So we could call that TC, transcribed into mRNA. Now, sometimes this mRNA actually does something in the nucleus, usually. I think there's cases where it's transported, but those are rather rare. They require a nuclear transport signal. Most of the mRNA that is functional, it's used inside the nucleus. But the most common thing is for the gene to export to it basically modifies that mRNA so that it's exportable, and then it goes out into the rest of the cell. And then it gets translated. Oh, damn. We'll patch that cell up there. Never mind. Okay, the next thing that happens is it's translated into a protein. So that's the translate. So we have transcribe, and then we have translate. Now, what I'm going to talk a little bit about the testes, and just in general, for any particular cell, there will be a certain set of DNA that gets transcribed. And then out of that, there's a pretty large subset that will get translated into proteins. And those proteins usually have a function in the cell. But at any step here in transcribing and translating, it's possible for spurious transcription and spurious translation. I think it's probably a little rare, but who knows? It could amount to 20% of the genes are not actually functional. It's sort of accidental that they got transcribed. And anyway, enough of that for now, but keep that in mind as we go forward. First of all, I'm going to try to do this right. So raw mat, standing for truth, we're picking on Erica over the subject of orphan genes. And they did a video in 2020, which I will link in my description. And basically, Erica, one of her arguments is that there's some papers that indicate that the most highly expressed version of orphan genes is in the testes, right? And first of all, I want to explain something about testes and genes. All the genes, all the orphan genes, all the genes that you have in your genome are in every cell of your body. So basically, they're in all cells. They're not just, expressed in one place or the other. Excuse me. They're not in one place or the other. They are expressed differently in different cells. Now, one of the quirks of the testes is that it unwraps the DNA because, of course, it has to make a gamete. And it has, when they test the testes, they use about 5 different tissues. So across those tissues, you're going to find high expression of all different genes. And they have some virus protection mechanisms and several other reasons why there's this quirk, where if you look at the expression of genes in cells, you will continually find the testes to be the highest expression of all, right? Now, the gametes, of course, get copies of all of your genes. In the female, that happens during embryogenesis very early. In the male, it happens a little bit later, hence the virus protection and all of that stuff. So anyway, all of your genes are in every single cell of your body. They are expressed differently in some cells. Okay? So from there, we'll go to raw mat. And this is hopefully a start of a series. You have to listen to a lot of Standing for Truth, but Raw Matt comes up with some things that are unbelievably wrong. Wrong Matt. He has no understanding of any of the science. Yet when he comes onto the stage and Standing for Truth channel, he gets all of this applause in the audience, like, oh, we brought out the big guns now. Raw Matt, he's so brilliant. And, and just for people who know a little better, listening to him is just like, what did he just say? And anyway, this is what he said, and I think it's kind of cool.
Okay, I will try again. No problem. Let's see, where do functions actually persist? So in the 2015 study that she looked at, she found that the majority of orphan genes were in the testes. What were their functions after they were inherited? What happens to them? Of course they're in the testes, because that's how de novo genes are actually passed on to the next generation. They don't arise sporadically out of magic, out of nowhere, because they have critical functions inside the human body. So of course they're going to be passed on and inherited. So that's where you're going to find a bulk of them. Where are the functions after they're expressed? Where, guys, we've been through this. We've had them from the beginning, and there are functional differences. That's it. Simple. We don't even need to convolute it by talking about it more. I mean, very simple.
Well, no, no. Well, I mean, that was awesome. I could listen to that all day. So
Related to one another, and yet there they are. So if it goes against a prediction, therefore it's a falsification. But regardless, they're there. They have they're separate in these different creatures, which they say are completely related, and their functional differences are vast and where they are. So yes, there's going to be more in it because they're passed on in the germline. So yes, you're going to find a lot in the testes, and then they're passed on. But that's like saying that women don't have them as well. Of course they have them.
that's a good point.
So what are they doing in women? Are they pointless there because they don't need testes to pass them on? No, of course not. They're functional in women, just like they are in female chimpanzees and monkeys. And the
Well, no, no. Well, I mean, that was awesome. I could listen to that all day. So
functional differences are what we're looking at and can help us identify separations between what is a kind. Very simple. Very not. See, I used to try to help and explain things, and it actually got more into convoluting the answer a little bit more.
He sounds like Trump in the convoluting answer a little bit more. I thought I'd include that part. But there you go. Twice, Raw Matt says the reason that they're expressed more in the testes is because they have to be inherited, which is such a sophomoric misunderstanding of germlines and how all of this happens. It is just unbelievable. But there you go. Now you'll notice if you transcribe that and try to make sense out of that gibberish, it's an amazing experience. But the important part is twice in there. He said that what he thinks is the genes somehow swim out of the DNA, gather in the testes, and get injected into the woman. And that's how you inherit genes. And I hope I've explained enough so you understand how hilarious that is.